Uh, Hello, my name is Alexander Gordeev. I work in Qualcomm, and today I'd like to discuss the draft virtio-video specification. It's a rather long formal text, and with this presentation, I hope to make it easier to digest to potential reviewers, and I hope maybe you will want to review it later and maybe even use. Uh, yeah. First, I'll talk about the scope of the specification and list some goals. Then I'll provide an overview of the current status. And then I'll dive into the main use cases and some design decisions, while also trying to compare it with some major video APIs. Yeah. So first of all, how many of you are familiar with like any video API? I'm really curious. Oh, nobody. Well, I expected that. That's why I'll try to like describe the problem a little bit. So yeah, how the video streams are compressed in general. There are two main sources of redundancy in the video streams. First of all, the spatial redundancy, or like finding similarities in the nearby pixels within a single frame, and also temporal redundancy. So finding similarities between contiguous frames, and so first thing is something like PNG, and the second thing is basically what you can see here. So there could be some different frame types. The first doesn't depend on anything. The P frames depend only on the previous frames, and B frames depend on both previous and future frames. And yeah, this creates a lot of trouble to the API developers. And yeah, because first of all, now we have to decode the frames in different order compared to the display order. So there is now decode order and display order. Yeah. Yeah. So there are two main types of video APIs: stateful and stateless. Stateful APIs look like a black box. You just provide some input data, and you get output data on the other end. It stores all the state between the frames for you. It parses everything, and it will also keep the reference frames. Remember the previous slide. And the stateless APIs will require you, or the client, to parse the bit stream, like take only the computationally heavy parts, provide all the context, all the state, all the references with each frame, and supply this to the hardware. So virtio-video spec is a stateful API because there is hardware that provides the stateful API, like we have in Qualcomm, and one can implement a stateful API on the driver side on top of the hardware providing stateless API, but other way around doesn't work. Yeah. So why would we virtualize video hardware? Obviously, to offload the heavy processing from the CPU to the hardware. How do we know that we do it right? So there are some tests that we can run, like vFoil2 compliance tests, Fluster, and Android CTS tests. Moment, yeah. Okay, so the next goal is that we should try to saturate the hardware. I mean, it should not wait unreasonably. And also we try to keep latencies low. The next goal, we obviously want to implementing the virtual guest driver on top of this virtio-video spec, like virtio-video device, as straightforward as possible. And also we want to keep it simple and easy to understand and extendable. So it is not an easy task, in fact. Because there are a lot of things that can change on the fly. And also because of all of these reference frames, and there are many codecs, different codecs, and some weird corner cases. And yeah, there are nice overviews that you can see for the weird corner cases. So basically, our solution is to gain experience and learn from other APIs and try to make it as best as we can, as good as we can. So there is quite some history already. Currently, we are at draft version 9. It's on the far end. And I already have enough internal feedback for draft version 10. But please do not hesitate to review it, and maybe you will shape the version 10. The virtio-video driver implements draft version 3 with some parts of version 4. So it definitely has to be updated, but it is in production since 2021, actually. So virtio-video was initially very similar to VFoil 2, in fact, with some parts taken from Virtio GPU. Well, I mean, I think they even took a lot of code from the Virtio GPU driver back then. It was not me. Yeah, except that compared to VFoil 2, the hardware capabilities were always provided in a single Virtio exchange. Over years, it was significantly simplified, sometimes oversimplified. Then last year, the draft maintainer decided to start from scratch with virtio-media, and so they wanted to use VFoil 2 user API directly with minimal changes. Yeah, well, makes sense to me for their use case. For our use case, it didn't really make sense. So I volunteered as the new maintainer for the virtio-video, and since then I brought back some complexity, but I took a lot of the ideas from GStreamer, in fact, because I know it quite good. Yeah, that's what I have done, have practiced for years, and I'll try to show why I did it, why I thought that it is better. So I'll try to go through use cases, but I'm sure I will not have enough time for everything. But so I'll start with the important things. How would we process a video stream? Of course, we'd like to avoid copying the big buffers. So we need to share them with the processor. Yeah, relocate them and share with the processor. Then we fill input buffers on the left. Then some magic happens, and we receive output data on the right side. Yeah. Actually, there could be multiple sets of output buffers. For example, an encoder could provide several resolutions, like medium, high stream, and low resolution at the same time. This is like good for like scalable video coding, for conferences. Yeah. So usually the hardware supports multiple independent stream, and they can run simultaneously. Like I try to show it here, but we can already see several queue-like objects on this picture, and now we need to somehow map them to the virt queues. So it's it's already clear that in some cases it is better to have as few virtues as possible. But while in other cases we can, like if we have more like memory or whatever, we can it can make sense to have more of them. So I'd like to start small with the only 2 virt queues, one command queue that queues the buffers to the and other commands to the hardware, to the device, and with event queue that basically delivers the delayed responses to the guest. It's called delayed responses because it's basically they are kind of independent, and this is kind of required because of the reordering. Otherwise, we can get stuck. Yeah. So how does a video stream processing look like in other APIs? So my main references here are vfoil2 and GStreamer, and I also said that I prefer some of the solutions in GStreamer. So yeah, please don't think that I hate vfoil2, but I will complain a little bit. Yeah, so it is done somewhat similarly in vfoil2 and GStreamer. There are like 2 queues. Yeah, well, for the simple case. In vfoil2, it is called output and capture. If you want to have multiple capture queues in vfoil2, well, as far as I know, you can only do this with multiple sub-devices and by using media controller API, which requires separate media device nodes in the guest, and yeah, it's quite complicated, I think. So it's basically for setting up topologies for very complex devices, in fact. For the virtio-video, if you want like have several output sets of resources, as I said, I think it looks like an overkill. Maybe we just need more output queues. Then we can build more things on top of that, like we can use fences, and probably, yeah, that would be already enough. But in some cases, there indeed might be some need for complex topologies. Yeah, and I like how GStreamer allows multiple source and sync pads, or sync and source pads. Yeah, that's kind of the idea. Yeah. So before we can process anything, we have to set things up. This is done with parameters. In most cases, the parameters change rarely, and also they usually can survive a reset or drain operation, which is basically some queue management. I'll get back to that later. Yeah. So I don't have time to name all the parameters, but I'd like to classify them. So there are multiple ways to look at them. First, some parameters define how the coded or encoded stream behaves. These are coded format, like bitrate and profile and level, and so on. And there are parameters that define the raw stream, like raw format, format modifier, maybe for tiled or compressed formats, then resolution and some hardware alignment requirements. And yeah, obviously we need to set up the resources or the buffers, actual buffers. Another way, like to look at each parameter, basically each parameter has some capabilities, like the device has some supported ranges for each parameter, and for each stream, this will be a single value, right? So on the left, there are examples of the ranges of the for every parameter, and on the right you can see the like actual values for the particular stream. Yeah. So I try to visualize it here. So let's imagine that on the left we have like a multi-dimensional space of all possible values of coded parameters, where each parameter is a single dimension. And the same thing on the right for the raw formats. Now, the figures in these spaces would represent the device capabilities. And if there is an arrow, then that means that the hardware can basically convert from some point from one figure to some point to in another figure. And like a stream would like represent the points in these figures. I think, yeah, it's the most intuitive and natural way to think about the parameters. So, how are the parameters represented in virtio-video? So, one of the goals was to minimize the latency. So, we want to get the capabilities and also get and set values using as few commands as possible. So I couldn't find a better option than TLV, which is a type length value. Basically, it's a very simple format. You just have type, you just have length, and arbitrary length value. And it's also very widespread. Yeah. So here, capabilities are represented on the left with a number of TLVs of type coded set, like you saw on the previous diagram. Then there is a number of raw sets and a TLV of type link that establish links between them. The values on the right use the same TLV container types, but yeah, but there would be only a single, like for the coded queue, there would be a coded set, one coded set, and for the raw queue, there would be one raw set. Yeah, this way we need only one command per operation. Let's look inside the sets. Yeah, so with capabilities we have the ranges. With values we have the some individual values, but you can see that the same types from like TLV types are used in both. Yeah, on both sides. Note that we can use default to control IDs in the TLV types. So there is like a block that changes the type space, right? I like how the default2 controls are defined. Like there is a huge page with all of the default2 controls. It doesn't make sense to redefine them. With like there are some minor exceptions, but in general, yes. So they are reused here. Yeah, and finally, some parameters can affect the resources or the buffers, the shared buffers, and other parameters will not affect them. So when we handle the the parameters that affect the resources, we should be extra careful, of course. And yeah, the other parameters can be changed easily on the fly without any precautions. So how do capabilities look in other APIs? Yeah, in GStreamer, I can start with GStreamer. So in GStreamer, we have non-fixed GST caps. Here's an example. In fact, it looks very similar to virtio-video's TLVs, except that there are no explicit links between like these lines, I would say, within the GST caps. In default2, it is rather complicated. So first you usually get yeah, there are a lot of IO controls that you should run. Oh, and yeah, then there are a lot of enumerations. It's when you like run an IO control with ID 0, then with ID 1, and so on, until you get an error. And also, like these lines are dependent. They depend on each other. And basically, you cannot just put all of them at once in the virt queue and just wait for the response. You have to, they are dependent, yeah. So this can lead to increased latency. Yeah, values in other APIs. It is similar with values. In GStreamer, we have fixed GST caps with the same keys, like in TLVs. And in VFOL2, there are again a lot of IO controls. Yeah, it's interesting that it is done differently with extended controls. It is somewhat even similar. So actually, struct VFOL2 X control is really similar to a TLV. There is also a type, a length, and a union with a lot of value types. Yeah. So actually, I even hope that maybe VFOL2 can adopt the this TLV format. So first, we can think it as an extension to the extended controls. Like first we extend it to the capabilities, then we extend it to other parameters, not only the controls in VFOL2 terms. Yeah. So next, it's also important how we set the parameters. There are two main ways to get and set parameters: in band or like serialized with the flow of buffers, or out of band, and like it can go ahead of the queue. It is okay if you don't need fine-grained control to which buffers the parameters are going to apply. In this, if you don't need it, you can do it out of order. But sometimes it is necessary, usually with encoders. Yeah, and also like modern APIs like Android codec 2 actually required. So I think it is better to. It is necessary to have a way to set them in band. So yeah, if we serialize them with the buffers, we can have fine-grained control, like to which buffers will apply the parameters. Yeah, so in fact, in virtio-video, it is kind of a default. Let's also look at dynamic resolution change. So in many cases, the parameters can change on the fly. For example, the resolution. When you, I don't know, when you have a conference and the bandwidth, network bandwidth suddenly changes, and you have to switch to lower resolution. Or you watch YouTube, the same thing, right? So it is basically a custom case of in-band parameters because they are stored within the bit stream in the buffers, and when decoding, yeah, we can. It is used here, and basically it is the same procedure. Yeah, note that the dynamic resolution change can also change the parameters. For example, if the resolution goes from this figure, we maybe want to jump to another figure, right? Yeah, so in other APIs, VFOL2 has many IO controls to get and set various parameter values. All of these are out of band, and there is a special API for setting parameters in band called request API. And it's also a part of this media controller API. It is rather complicated, and it's basically not a default, and it only works for the controls, which is like a limited part of all the parameters. And there is a special procedure for handling resolution changes. In GStreamer, we just have GST event caps. Well, there is also caps negotiations, but basically you just receive GST event caps on the sync bed, then you send on the same, well, again, GT event caps on the source pad, and you're done. It's all in band. Yeah, I'm not going to gather, drain, and reset. Sorry. If you want, you can look at that later from the presentation. I think the virtio-video spec is now clean. It provides easy and consistent solutions in common cases. But yeah, as I said, there would be also version 10 to clean up it even a little bit more. This is mostly the result of taking the best from VFOL2 and GStreamer. I don't expect that VFOL2 can somehow become more consistent here because they have a lot of legacy. Yeah, that definitely can happen. But that will, I think, require a lot of time, and somebody has to do it. Unfortunately, we don't have enough resources to also change it right now. Yeah. So as I said, there is the virtio-media device specification. It uses VFOL2 directly with few modifications. I think, yeah, there is certainly a use case for that. Like, as far as, well, when I think about it, I think, yeah, when you have VFOL2 on the host and you just want to get it in the guest, yeah, certainly it makes sense. So, but I'm coming from automotive, and I don't remember a single case when we just had the VFOL2 on the host, and yeah. So there are also other things to consider, and yeah. Thank you. I hope it makes sense to you, and please review virtio-video or even both specifications. And yeah, if you review version 9, then the feedback would be addressed in version 10. Do you have any questions?
You talked a lot about the specification. What about an implementation? Is there something out there?
Sorry, the last part?
Is there an implementation already available that some patches that are on some list or somewhere in the public?
Yeah. So there is a virtio-video driver in the public developed by us, and there is also, I think, an virtio-video device implementation in Rust VMM, as far as I know, which I'm not sure if it's supported now, but yeah, probably it works. We have our custom proprietary implementation, unfortunately, right now, and but yeah, let's see. Maybe it can change in the future. Maybe one more question. Okay, thank you very much, and